Yeah, it went back to work. So. Okay, don't know what went on with Zoom, but we got it back. And didn't interrupt anything. Okay, so as I said, don't see the kind of preparation that I would hope for. So make sure when you do your assignments, you keep pondering, what does it take to understand this well enough to do a couple of straightforward problems, okay? And the other thing, I think, and I'll put it on the assignments page and send an email. I'm gonna start requiring that you write out your work and bring it to class. Okay? And I'll be evaluating that as part of the quiz. You know, generally, while you're doing your work, I'll circulate around and just look in general, you won't be able to look at every detail. But I want to look at how you're writing things out because that's critical to the learning process. And there's a temptation, and I've said this before, probably a dozen times. There's a temptation to just do whatever gets the answer as quickly as possible. It's not how you learn. Okay. And I recommend that you write things out the way you see me writing them out. Or if you prefer, write them out the way you see on the open math videos. Okay, with words in between that state what you're doing, because that reinforces it for you. Okay, also if you're having problems, it shows me what words you're using and it shows me what you're thinking. I can't always tell that just from the symbols you write down. Okay, now I can tell from the symbols you write down if you're getting this off an AI. Okay. I'm not going to grade you down on that. Okay, there's your credit for homework. That's 10% of your grade, and you're going to fail the rest of it. Okay, and if you don't fail the rest of it, that's fine too. If you can pass the test, I don't really care much what else you do, right? But most of you are simply not going to learn the material and pass the test unless you develop an approach that results in learning stuff well enough to perform. Okay. Then again, your day to day, you have these assignments. Okay. Do what it takes to learn, not just get the right answers on a computer screen. Okay, write it out. Bring the writing class. Okay. So I'm going to go through this kind of briefly because we've got other stuff to do. We've been over all these ideas. So there's no idea that you're going to see here that's any different than ideas we've already used. Okay, so f of g of x. G of x, I'm sorry, f of x is this. If I replace x by g of x, I get f of g of x. And then if I replace the symbol g of x by the formula for g of x, we have this in the domain. I can put any number at all into this except -3. X can't be 0, so x can't be -3. The domain is set -infinity, -3. And I don't know why I use set notation. Union, -3, infinity. All real numbers except -3. G about that. Well, here's my g of x. I replace x by f of x. By writing this down, I've replaced x by f of x. So I've got to replace F in the definition. If you look at the definition and you look at what I've just written down, you see that X is replaced by F of X. Again, because this X got replaced by F of X. Now, of course, then we write down our whole expression for F of X. F of X is this. And then plus 3, which is 1 over 2 times the quantity X minus 5 squared plus 10. Well, all right, is there any X that we can't use? X minus 5 squared is always greater than or equal to 0. If we do 2 times X minus 5 squared is greater than or equal to 0. And then if we take that and add 10 to it, that's greater than or equal to 0. X has no restriction. Now, what I haven't written down is the denominator can't be 0, but that's what we're testing. The denominator isn't 0. It's greater than or equal, it's greater than, sorry, actually greater than or equal to 0. It's greater than 0. If I take something that's greater than or equal to 0 and add 10 to it, then it can't be equal to 0 anymore. Okay? And then it's greater than 0. So no restriction. The domain is negative infinity, set of numbers from negative infinity to infinity. Okay, that's that. Now, this second question, we'll get it and we'll get a rate of change. Rate of change is maybe the most important idea we encounter in calculus or pre-calculus. So you can expect me to emphasize it. Now we're just asking for the average rate of change with respect to X on the interval -3, -2. So F of -3 is 3 times 2 to the -3 plus 4 plus 8, which is 3 times 2 to the 1 plus 8, which is 14. And if you're writing these things out, I don't want you to plug this expression into the calculator. I want you to work everything out that you can work out just by standard multiplication. I want to see the steps. Because again, people are not as good as they need to be on, many people are not as good as they need to be on following steps. Some people are pretty good with it, but on the whole, and that's a potential stumbling block for this class, okay? For most of you. You want to write it out. You use your calculator. You don't need your calculator for this one, but if you do, that's okay. But simplify it first. 2 to the 1. 3 times 2 to the 1 plus 8. Okay. Then F of -2 is 3 times 2 to the -2 plus 4 plus 8, which equals 3 times 2 squared plus 8. And we can write a little more on that one. That equals 3 times 4 plus 8. Now we can say, okay, that's 12 plus 8, that's fine. don't want to get ridiculous with it, but there it is. Which gives us a picture. And I want to see that picture in your paper when you work these out. Okay? If I see the picture on your paper and you screw it up on a test, say, you're gonna get more points than you will if you screw it up and I don't see the picture in the paper. If you don't screw it up, then it's okay. If you get it all right, don't screw up anything, you're gonna get your credit, okay? Unless I ask you to show the picture, which I will in many cases. Okay, so what's this say? This on a graph of X versus f of X. Okay, well, we've got X equals -3. Now, these construction lines, these vertical lines, the construction lines that I ask you to, or that I require that you put on a constructed graph, so you know where things are and you're oriented. Now, you should do the same thing on any graph. Okay, you don't need to make 100 marks along here and then figure out which one is -3. You just slop down -3. Okay, once you slop down -3, then of course, -2 had better be closer to -3 than it is to 0. So you're gonna put -2 maybe here. And then we got y values of 14 and 20. I'll start with the top y value. Here's y equals 20. And if this is 20, 10 would be in the middle, 14 a little closer to 10 than 20, so 14 might be about there. I think I've got it a little bit too low, but it's okay. This is a schematic. It's a reasonable approximation. Now, if you do y equals 14 and put it down here, then, I'm going to probably consume a little bit. Okay. Or if you put it much closer to the x-axis than the 20, well, you got to understand that 14 is more than halfway from 0 to 20, at least. Okay, so anyhow, you got that. Okay. So now we know that we have the point -3, 14, and the point -2, 20. There are two ways we can go here. I can say that the average rate is f of -2 minus f of -3. Well, actually, I want to see right out more than this. I want to say it's the change in f. Or if you want to call it the change in y, then you just put a y equals f of x. It could be the change in y. I'm not going to quibble about that at this point. But it's a change in f divided by the change in x. What's the change in f? It's the later value minus the earlier value. Now, if this is think of a timeline, -2 comes later than -3 if you're moving in the positive direction. So I'm going to say, okay, we want x to change in the positive direction. It's going to be -2 minus -3. Okay, the change in f is going to be going to write it out. F of -2 minus f of -3. Got a function, it's always going to look something like this, and you've seen this in open math if you've read the text and watch the videos and so forth. Okay, it's got to be -2 here minus the -3 value because it's the -2 minus the -3 value here. And f of -2 is 20. F of -3 is 14, and this is over -2 plus 3. Average rate of change is 6. what I want to see on the picture, and I will ask this. So I want to see this, what I call fundamental triangle, which I've explained a couple of times, emphasized that it has to be totally labeled. And I think on the test that I got, which didn't look terrible, had some good points and some errors. But I didn't see any fundamental triangles. There's a question on it. Now, I haven't looked at them that closely. I just picked them up 5 minutes before class and leave through them while walking back. Okay, now I ran into a few things and that distracted me. I saw a lot of stuff that looked pretty good. I didn't read the words in between. I didn't look at all the details. I didn't even look at what the problems were. So I don't know how well people did or how poorly, but I saw a lot of the stuff I would look for on pretty much most of the tests that I picked up. Okay, but there weren't that many of them. Okay, well, anyhow, so the fundamental triangle. I mean, start from this point, you make an arrow from here to here, you make an arrow from here to here, and a line from there to there. And you say this is the run equals -2 minus -3 equals 1. If you will do this, it reminds you of the order in which you subtract these things. It relates to this picture. It makes sense out of this expression here. Okay, and the rise is 20 minus 14 equals 6. You write this down like I'm writing it. And this I do require. Okay? Because I want to focus you on what this means. I want you all to go into your calculus class as people who are prepared to actually remember some of what you learn. Because most people in calculus class never do. They learn it short term, they forget it as soon as the course is over. And there's a lot of insight that you can get from calculus that's applicable in everyday life. It's applicable in different professions and so forth. Even if you never do actual calculus, there are insights. And this insight into the idea of a rate of change is really an important one. Not just in education, not just in career, day to day. If you understand rates of change, you have amplified ability to think about things. Okay. There are other ways you can be amplifying your ability too, but that's a good one. I mean, not just mathematics, but okay, now the slope equals rise divided by run. You want to keep reinforcing it. You want to keep writing that out. It only takes a couple of seconds. Write it out until you're sick of it. Okay? It'll benefit you. Not being sick, but writing it out will benefit you. Okay? And that's 6 over 1 equals 6. And then, now I require this, but nobody else will know what you're doing. Still, for your own sake, you write it out here so you can immediately see. This is the slope, this is the rate of change. Okay? The slope and the rate of change are interchangeable quantities, except the slope has more meaning than the graph. I didn't give you a meaning to interpret, but I could have. And I probably will. Certainly when we have a test over chapters 1 and 2. Okay? So all that should be done if you really want to understand rate of change every time you do a problem. And it doesn't take long. After you've done a few, it becomes automatic, but you're still thinking and you're still reinforcing what you're doing in a way that will benefit you. Even if you don't take calculus, the idea of a rate of change is an important idea. In calculus, it's a central idea of the first semester. At this point, you should know how to graph this function. Okay. So I'm gonna change the name of this function to G of X. Now G of X equals A, alpha of X minus H plus K. For what function f of X? One of our toolkit functions. Which toolkit function is involved here? Okay, now, the reason for the whole set of stuff that we did before we, up through last week, and that we were tested on or going to be tested on late, is so you'll be able to see what the graph of this thing looks like without having to punch buttons and look at a screen. Okay. So that you can think in terms of this function. Anybody who had done all the homework that was assigned and done everything in a timely fashion would be ready for that, but almost nobody did that. Okay? Everything in this course builds on what's going before. So the stuff that you're testing on today is not going to go away. I'm going to be quizzing you on it, testing you on it. Every time you're tested or quizzed, okay? So if you haven't mastered it, you need to master it. It's totally achievable. And then it starts by being able to construct these graphs and then understand if the red dot is here, then this is what happens to the function. H and K are the coordinates of the red dot. So you got H and K right away. So we know where the red dot's going to go here. Okay, we know it's going to be an exponential function. Now, the one thing that we need to slip in on is what we do about this 3 here. Okay. So I call the basic toolkit squaring function. Squaring function, exponential function. And A is still a little mysterious. It'll be mysterious until we get here. In other words, I'm going to tell you what happens for A, at least for this function. Okay, what happens to A? So, first of all, write down what are the coordinates. What are the two numbers? What are the two coordinates of our red dot? I just told you on the board there, but let's see if you understand that. Okay, well, I don't think anybody got it right. Okay, so let's see how we analyze this. Okay. That's 3 weeks ago today when we listed all the AF of X minus H plus K. Talked about function notation, okay? and talked about, how to do pretty much everything you need to know how to do. And then you had an assignment on it, okay? Ideally, by the time you did that assignment, you'd be pretty good with function notation, okay? Or at the very least, good enough to understand what I'm telling you and understand that you need to understand it better, okay? So can you write out what f of x minus h plus k would be if f of x equals 2 to the x? Okay, can you kind of quickly write down for me what happens? Okay, well, everything else is pretty easy, but we want to focus on what is f of x minus h. So can you write out what f of x minus h would be if f of x is your basic toolkit squaring function? Okay, can you write this down? Everybody write f of x equals 2 to the x. Write it down, f of x equals 2 to the x. Then write it down again, right below, okay? The second time you wrote it, I want you to erase all the x's. Okay, everybody got that? Got it written down twice. First time, you've just written it down, haven't done anything to it. But the second time, you erase all the x's. Okay? Now, for the second one, where you erased all the x's, replace them with x minus h. Okay, now, people did well with these instructions, and you want to review this, you want to make sure you understand what we just did. 100 times, or it seems like it, at least a dozen times, I said you replace x by whatever's in parentheses here, right? And people are still not doing it, but now when I say write this, write it again, right? And then erase the x's and this one, to leave this one the same. And now every place you erased x, put an x minus h. If this is true, then this has to be true. Okay? And this is what we did wherever it was. Can't find the board, but what we just did when we did f of g of x and g of f of x with the functions in the quiz. Okay. It's just replacement. If it's f of g of x, then you replace, you write it down twice if you need to. Then erase your x's. Or write it down with blanks where the x's were. Pretend you'd erase them. You don't want to mess up your paper. That's fine. Okay. But then whatever you replace x by here, you replace x by here. Whatever the expression is. Okay? That makes sense? That's all there is to it. Now you got to figure out domains and ranges. So we illustrated that. And it's in your open math. Probably don't want to review it. Okay. So now if f of x minus h is this, what are you going to do about a f of x minus h plus k? Just write it out with a's and h's and k's. Okay, we figured out what f of x minus h is. It's 2 to the x minus h, right? So what are you going to do about a f of x minus h plus k? You're going to write a times 2 to the x minus h plus k. You're just replacing f of x minus h with 2 to the x minus h. Okay? That's all. Now, can you write out what g of x? Okay, you know what g of x is. Finally, I hope. Okay, g of x is a f of x minus h plus k. We've said that. Okay. And what are a, h, and k? Okay, well, people are telling me that a, which is what goes in front of the 2 to the x minus h, is 3. Pretty obvious, right? So a is 3. H equals what? Well, it's 2 to the x minus h is 2 to the x plus 4, right? If x minus h is x plus 4, well, most people want to write down h equals 4, but no, because if h was 4, you get x minus 4 for the exponent. What are you going to do about that? You'll put a negative sign in front of that 4. So that x minus h would be x minus negative 4, which would be x plus 4. And I think most people got k equals 8. Okay. Now, what does this have to do with what we spent 3.5 weeks trying to learn? And what you got tested over? Okay, comes down to this. Okay, first of all, where's the red dot? If you weren't able to tell me before where the red dot is, fill in the coordinates of the red dot and circle that so I can see it when I come around. Okay, so we had to digress to all this to figure out that the red dot was at -4, 8. Now, if I ask you to construct a graph of an exponential shape with the red dot at -4, 8, you do that. Okay. I think most of you can do that correctly, but I haven't seen enough tests to be sure. Okay, and I haven't looked at the tests that people did take. Closely enough to see if that's the case, okay? But oops, let's make it red, it's a red dot. Okay, so now we know the red dot is that the point -4, 8. Okay. Now, I'm gonna construct a rectangle, and construct the exponential function, construct the exponential function. And without comment. If you can't do it that fast, practice until you can and think about what you're doing when you do it. Okay. Now that should be familiar, and I think it is to most of you, and hopefully to all of you. There's your exponential function with the red dot at -4,8. Now, the one thing that's different now than it was when I did on the test. On the test, I didn't have any, the only value of A would have been 1, because I was just doing f of x minus h plus k. Okay. Now we have a value of A. On the test, your rectangle is always 4 by 4. Well, now your rectangle, it's still 4 units down here. But up here, it's 3 times 4. So that rectangle, it still looks like a square, but if you draw it to scale, it's stretched out and it's 3 times as high as it is wide. So it's got dimensions 12 by 4. Okay. Okay. So tell me, what are the coordinates of this point up here? And what are the coordinates of this point here? No, that wasn't necessarily important when I thought. I kind of lost track of when I put it on, when I put it off, but you know, we've established that the red dot is at -4,8. So we draw a red dot at -4,8. Then we sketch a rectangle. Okay, rectangle is still going to be 4 units wide. But because of the 3, which multiplies the f of x minus h by 3, it's going to be 12 units high instead of 4 units. Everything on the test, everything up to this point, we had a 4 by 4 rectangle. Because of the 3, that vertically stretches things. Okay, so that this, on this scale, this is no longer 4 units, it's 12 units. It's like stretched out. It doesn't look like it's stretched out, but because of our scale, it is. Now we've constructed the Woolkit exponential function. I asked for the coordinates of these 2 points. And I think I'd already done that on the video. And then I said, no, you need to label your construction lines. Okay. And you should be able to label them rather quickly if you understand the numbers and if you understand the coordinate plane. And if you don't, you got to keep doing this until you do. Okay, so this is x equals what, this is x equals what, and this is x equals what. Okay, so let me see how many of those construction lines you've got labeled. Excellent. Okay, we need to be making a connection here. People are having some trouble with this. Okay, well, this line is x equals -4. And this line is halfway between here. Well, this line is x equals what? Well, this thing is 4 units wide, 2 units on this side, 2 units on this side. So if x is -4 on this line, then x equals -2 on this line. Go 2 units to the right, we get to -2, and over here x would be -6. Now, if you got -2 here and -6 here, you kind of label it backwards because we want to have increasing values of x. Okay, so you want to fix that. Now, most people have the fact that y equals 8 here because this line goes through the red dot. A lot of people are saying y equals 12 up here because, well, you have the good habit that you develop for the test. Every rectangle is 4 by 4, but this one isn't 4 by 4 anymore. It's 3 by 4 by 4 because of the 3 that we multiply f of x minus h by. So this would not be 12 because from 8 to 12 is only 4 units. It's got to be 12 units, which means it's, well, let's say it's got to be 8 plus 12, which is 20. Then this is halfway between here and here. Halfway between 8 and 20 is 14. This is halfway between 8 and 14. That makes it 11. This is halfway between 8 and 11, which is 10 and a half, 9 and a half. And this is halfway between 8 and 9 and a half is 8 and 3/4. Now, I don't know everybody got them halves, but you're going to need then the coordinates of these points are what? X is -2, y is 11. Y is 11, y is 20. I don't know where I got 11. Okay. At this point, x is 4, -4. Now I could ask you to calculate the average rate of change here. So I'll just kind of sketch one of those in without doing all the explanation. I can do this. Again, the average rate of change from here to here. Now that's asked on the test, okay? Okay, now what has happened here? If we start off with the y equals x squared graph, y equals 2 to the x graph. It's going to be like here. I made this graph a lot narrower because this is supposed to be 3 times as high. Okay, so my y scale and my x scale aren't the same. What's happened is the red dot. Whoops. That's -4. So I'm going to pull the board over. A bit more reasonably. And actually, I'll kind of do it to scale. If I move over 4 units and then down 8 units, that would put my origin about there. It would give me pretty skinny rectangle. No, I'm not going to draw all the lines, but I'll just indicate. Here's my dual fit exponential function. This point is 0, 0. I could label these lines. And I don't really have a position corrected. But okay, what we do is we first stretch this graph out. Okay, this is 4 by 4. We stretch it out to 12 by 4. And it's going to look, well, it's going to look like the one we just sketched. Without drawing in all the construction lines. And then This is what we take. And move here. You know, we imagine doing this here. I can't do it here because I've got all the labeling, but I'm gonna kind of do one anyway. Okay, so we stretch this one out, so it's. Then we're gonna get points like here, 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 and here. So the original was 4x4. Doesn't look 4x4, but I can use any scale I need to. And this is 12x4 with the red dot still at 0, 0. Now what I do is I move the red dot over 4 units. Okay. And I move it up 8 units. And move it left 4 units, up 8 units. Now this graph then is what? This graph would be A times 2 to the X, the purple graph. The white graph, and it's 3 times 2 to the X, so. Well, A times 2 to the X, which is 3 times 2 to the X. This graph here is this y equals 2 to the X. It's our basic squaring graph, our basic exponential graph. Then if we just move it over to here, it would be A times 2 to the X plus 4. If we move it up here, we got to add 8. So we have a horizontal shift. -4. Vertical shift plus H. And a vertical stretch. Would like to say by a factor of 3, but I don't have room to write that out. So we take this thing, we stretch it out. Okay. Then we move it over and we move it up. We stretch it, then we horizontally shift it, then we vertically shift it, and there's our new graph. And hang with me for just another minute. This graph is y equals a L of x minus h plus k equals a times 2 to the x plus 4 plus 8. I'll call this g of x. If x equals -2, g of x equals 1. You just plug -2 in here, and in fact, we did that. Whatever it is, what did we do that? Oh, there it is. Okay. Now I called it f of x over there, and it's g of x here, but if we evaluate this function for x equals -2, we get 20. If we evaluate it for x equals -1, we're going to get 14. It's right there. Therefore, yeah, x equals -3, which would be here. There's x equals -3. Okay, they're my X value. In other words, if we did this from this point and this point, we would get the same triangle we have here. We have x equals -3, here's x equals -3, x equals -2, here's x equals -2, y equals 20, well, there's y equals 20, y equals 14, there's y equals 14, and right here is the triangle that we drew here. And it all comes together. Now, you've got rules for horizontal shifts and vertical shifts and vertical stretches, okay? You also have a horizontal compression that you might see, but not a lot of, okay? Matter of fact, I don't think I put it into the problem set. Maybe one problem. We're not going to worry too much about horizontal compression. But the whole purpose for the first 3 weeks, and the idea that everybody would master this in the first 3 weeks, was so all this would be obvious, so you would really understand transformations. Okay? People haven't mastered it as well. Most people haven't mastered it. Some people maybe have. They're gonna have to work a little harder to pull it together. But do the assignment, learn what the rules are. And the reason for the rules is what we did for 3 weeks and what you were tested over. Okay?